Hey, my name is Bob Rosania. I'm one of the lucky people in the world to have FSHD, but I'm also very lucky because I'm with some great individuals here who are working based out of the University of Nevada, Reno, Peter Jones Group, doing some epigenetic research. This gentleman here, Ryan, if you don't mind, just you want to say hello?
How's it going?
Was a real catalyst to helping bringing this whole group and the technology together in the effort. So.
Yeah, this is Nick Murray with sports science and neuroscience, and yeah, we're going to do some assessments of walking and begin looking at whether this is a good outcome measure for FSHD clinical trials.
Very good. So the first step is for me to start.
So we're going to get your weight first, and you can go ahead and support your weight if you need to.
Okay. No, this one I think I can take a little step with this.
Okay.
82.2.
82.2. Perfect.
Okay. That's kilograms, by the way. If it were pounds, I'd be in real trouble.
Okay, I'm going to take your leg length on both your left and right.
Okay.
Just hold your brain and foot measure.
And for those that don't know yet, I broke my foot on a fall about, 5 or 6 weeks ago? So it's been healing. But it was an odd break. It was the lateral cuneiform bone, which is very protected. And it was just the way it fell in it. When I was diagnosed.
Injury originally.
One more time.
I felt I was getting up to use the restroom early in the morning, and you know how it is. You're down on the ground before you know it. This one took a big chunk out of the bottom of my foot.
No, I'm 78.5.
So I had a big avulsion chunk out of the left foot. And trying to walk on two. It was not fun.
279.
So we have 2 and 78. Okay. All right. So the first thing we're going to do is we're going to get oriented to the platform. And essentially, this is just a pretty standard. There's tiles on each individuals here. So each where this name is, there's a tile, and it's going to register footfalls. So here is a non-censored portion, and the end is a non-censored portion. So what we're going to have you do is we're just going to check the calibration real quick.
Right.
Just have you get accustomed to it. Just walk straight down, and we're just going to take a look to see how the
Ready?
walk as normal and comfortable as possible. All right. How'd that feel? Good. Okay. You want to come back around for us because we're going to do everything from this portion on. Did you get sensitivity?
I need to stand.
Okay. You want to stand on? Oh, we're doing calibration.
No, I need to look sensitivity and stand. Just stand there.
Okay. Yeah. So if you want to come right up and stand right on this first portion here, and we're going to check the load cells.
Feels like a sobriety check.
Actually, so kind of one of our main things that we do is we actually handle head injuries. So we do with sports medicine, we handle sport-related concussions. And we actually do give a series of sobriety tests, essentially to test people's balance. That's why it's lying here. It's actually supposed to walk the line. All our athletes go, I'm like, so, okay, walk the line. Like, oh no. We're great? Okay.
Calibration.
All right.
Johnny Cash fans here and walking the line. Okay.
All right, so we're going to go ahead and step off of it.
Right.
And I'm going to demonstrate what we're going to do for the calibration. And this is where we're going to have to balance on one leg. And we may have to do a couple different trials, but it should go, we're going to go down each tile itself. So we're going to step on just like this after we hear the tone and hold it here for just under 10 seconds. And then we're going to step right off. And then we're going to go down, and we're going to do it on the next tile. So we're going to do that 5 times. Go ahead. Okay, we're good. Step up. Perfect. And we'll go down to this one. Okay, good. So if we actually do want to pull that left hand leg up, that right one.
Today.
This recently as well?
Yeah, I did it yesterday.
Did you pass?
I didn't. I almost It's okay.
So we're gonna do 3 healthy trials just to take a look at how normal you walk. And the reason we do 3 is typically because the first time you come and do something like this, your first trial, you always kind of walk different than you normally would. So whenever Brian indicates that he's ready, we're gonna go ahead and just walk normal pace down to the end. Perfect. Go ahead and come back around. And let us know if there's anything fatiguing or if anything is getting a little tired that we should be aware of. How many footfalls did we get? 5? It's interesting, 'cause yesterday we got average
I was
eight
at 7 or 8, yeah. Take small strides.
Yep.
Watch that finger now. Level.
So you run a blog for the community or?
Yeah, I started a blog called the FSHD Lab Rat because I looked at doing studies and trials personally of one. So that was around the time I went to Gait Mechanics.
Okay.
Good.
All right. We get all 3 trials? All right. Now we're gonna do some fun stuff.
Okay.
Okay? So we'll go ahead and back over here, and what I'm gonna have you do is you're gonna walk just normal, just like you did.
Mhm.
Yet I'm gonna have you do what's called a dual task,
Okay.
which is I'm going to give you a problem to solve while walking. And we're gonna analyze your gait based on how we're able to do 2 things at once.
So it's like walking gum and chewing.
Hey,
Or
walking and
and
chewing gum,
at the same
exactly,
time.
which I have a big problem with. So here's the first problem that you're gonna solve for us. I want you to out loud count backwards 5 sevens, starting with 100.
Oh my goodness, okay.
Yep.
And how about if I don't make it to 0 before I get
Totally fine. Some people only get maybe 1 or 2 down. That's fine.
My 7's backwards.
Exactly. So whenever you're ready. Don't think too hard.
Okay, all right. You ready?
Go ahead.
193, 76, 69.
Good.
That was good.
Perfect. That's great. All right, come on back. We're gonna do another dual task for you.
This one's harder.
Just for fun.
How about the Fibonacci series?
Exactly, right?
Really well.
So we're gonna do the months of the year in reverse order, starting with the month that I give you. Okay? You guys ready?
And you say this is fun.
It is, right? April.
Okay, ready?
Go ahead.
April, March, February, January, December, November.
Good. Perfect.
I crossed the year. So.
That's fine. Totally fine. You get extra credit today. Okay.
Maybe I get extra credit for that.
All right. So that's actually as long as the testing takes. Pretty quick, pretty easy. So we can go and get your shoes back on, and what we'll do is we'll run some reports and we'll just take a look at it.
Fabulous. And I bet you're going to conclude I didn't have a head injury, at least.
Yeah. Yeah, that was Ryan yesterday. We were a little concerned about that.
And just to be clear, Nick, what are you actually calling this test?
This is just gait mechanics. So what we're looking at is just how you engage during walking tasks. And so what we're essentially looking for is different alterations in your movement patterns that we may be able to track as monitors. And just remind me, what are some of the key variables we're looking for with the rats?
You know, so we can do the same thing with mice. So we can actually relate the mouse models into the human pathology. And so we're looking at stride length, we're looking at times, we're looking at, yesterday with me they found pretty interesting active propulsion that was severely decreased, which makes sense.
Essentially, Ryan had, because with human motion, you have a series of, essentially, gait is what we like to call a series of controlled falls. So all you're doing is you're controlling your forward momentum.
Yes.
But at the end of that momentum, you have an active propulsion that pushes you forward. What we saw in Ryan's case, he didn't have any active propulsion. All he had
Is that to press off to move forward?
Yeah. So yeah, basically you're using your gas rod primarily. And so I don't have any of that, which makes sense because my gas rods don't work all that well. So.
Do you have a patella response, or is that now pretty much dead? Because mine is pretty much gone.
Yeah, I don't.
I would like to see before we leave a mouse counting backwards from 100. That is a dual task.
I was thinking about that yesterday. Like, how could we get the mouse to do little tasks? It's like, well, maybe you could have them,
Yeah, I'm not sure.
respond to a button press.
Focus on some cheese or something.
So we have trained muscular dystrophy mice with food
Yeah.
quite a bit. And the muscular dystrophy mice, because of the metabolism involved, are actually, they end up looking like they're smarter than normal because they're so food motivated. It's actually an interesting, we were testing whether or not the intelligent, whether we can see a difference in intelligence because there is problems with the brain and the white matter, I think, right? And so it was kind of an interesting, this is actually for DMD mice. But yeah, they're extremely food motivated, so they will do almost anything in order to get food.
That'd be really interesting. I wonder if, yeah, because
I don't know how you set that one up. But
You can train them to the strobe lights, and then you can put them on the platform, right? Just like they're going to get the food, right? So
Yeah.
they'll be trained that way. So they'll be thinking about food, but they're
Right.
trying to walk.
that actually might be enough too.
Yeah.
Yeah. Because what we're trying to do with the dual task, and we do this a lot with our head injury patients, basically you think about it, you've got we call it a neural reserve. You just got a tank. And it's how much you can do at that time without having a breakdown in the system. And so when we walk, walk, text, walk, move our phones, there's a reason why they say don't use your phone while you're driving, because you split your attention. And you almost always focus more on your actual phone than you do the actual driving part, which is the causes the crash. So in our concussions, at least, there's a lot of deficits that we can't see until we give them some sort of a challenging cognitive task. They actually will do just fine in their natural environment, and they'll look great until we say, now you got to think about the play and execute the play at the same time. So we're believing that there may be a similar category with FSHD that we're looking at, to where it's not that you guys have a compromised cognitive status, it's just your motor response should change when you have a dual task, some sort of.
Well, I know personally I have I have to focus a lot more on my balance. You know, so it's taking a lot more of my processing power just to walk because of the missing muscles and the muscles that are unbalanced, the asymmetry there. And so because of that, I think the cognitive task is really hard.
And I think in my case, sometimes, I'm sure you can relate, when I'm walking, oftentimes I am thinking about every step.
Oh yeah, you're looking
at. It's going to be the one, so in and of itself, it's actually a
exactly. You're looking for cracks. You're looking for slopes. You're looking for what's the angle that I'm stepping on, because if I step on the wrong angle, I don't know what angle I'm going down.
Right. Even a bit of
I'm looking
fear, having a fear.
Oh, it's complete fear. Yeah, I'm looking for where am I close to walls? Because if I'm in an open field and I fall, I'm not getting up. I need a couple of 200-pound guys to help me get me back up. So no, I'm looking for walls that I can get back up on if I do. Yeah, exactly. You're looking for all that's going on in the. So you take that away, you start focusing on something else. You're probably going to get more realistic. How you actually walk when you're not focused.
Right. And this analysis that you folks have done, it only took about 5 minutes.
Yep.
So very good. So let's see what our data shows, right?
So essentially here on this actual pressure platform, you can see each of the footfalls. So here's your right foot, and here's your left foot. Here's your right foot, here's your left foot. And you can see the actual pressure distributions under each foot. And like this one, for example, you seem to come down on your heel, yet you don't really transfer your weight fully. And so we're looking for in a natural gait pattern is a really good footprint.
Well, I suspect that's probably due to the fact that maybe the brake is changing, so
It's
I'm not
possible.
rolling my foot as much to take it easy.
Are you doing the left foot?
And you also have it on the left foot.
Okay.
If you have a break, there's going to be accommodation, but if you're 5-6 weeks post, you probably won't have any more accommodation. The accommodation is probably coming from wearing that boot more than anything else at
I
this
see,
point.
okay.
So then this is our, which one's next?
So click on this one. Let's do one.
Uh-huh.
So was green good and red
This is
bad, or
the-
doesn't
That's-
matter that way?
Those are just left
Okay,
and right, left
okay.
and right.
So this
Yep.
is dual task when
Okay.
he was counting backwards.
Okay.
7.
Okay, so this is our dual task condition, and you can't really see it. We'll show you it in the actual data itself, but you see the same pattern here with your foot. And so what we're looking for here is kind of, is the data repetitive in terms of the same footfall characteristics, and what is that telling us about the actual disorder itself? And so I'm seeing again the same pressures occurring in the foot, where you're not going through the full heel to toe stance portion to propulsion, which means in my mind here that you may have actual more propulsion than what Ryan had. Your left side looks like you have active propulsion and your right side looks like you only have passive, which means that essentially your left side is a strong side, your right side is weaker than that. And so
That's
we
right.
would then analyze your left and right leg independently to see what each one tells us and maybe how the progression, because it doesn't.
Right, and I
work
am
by
asymmetrically weaker on the white, so it's interesting it's showing
You
that.
can also see the distance increases compared to the first one because there's that dual task interference. You are slowing down your stride distance between the both foot. Also, the velocity decreases. So those are some of the parameters evaluated in this literature for this population.
And is that
Very good.
atypical relative to a healthy
It's
individual?
normal for you to actually, so average person, if you start to do something a little bit more challenging, you're going to take shorter steps because it needs to be a more conservative strategy. Because you need to think about what's going on. So this is what we would see, normal pattern. But what we would do then is we'll compare this data to a healthy control, same age, same height, and essentially take a look to see how they would have the same distribution, and if it is. Do they reduce their velocity or how fast you're walking? And is their stride step distance here reduced as well?
And in this case, just to be clear, it really wasn't, or it increased?
It decreased.
It decreased.
Oh, it did
Yep,
decrease.
You
it
passed it
decreased.
on when you were doing a dual task.
I see,
Yeah.
okay.
It's normal, but we also see in the
The Excel
population
sheet's
how
back
much.
behind, so you can actually show them just the numbers.
Alright.
Yeah. So this would be our numbers.
So that all gets.
That explains it very clearly.
Yes.
The nice thing is this software gives numerous variables, and we can analyze all of those and look at what would be a marker to look at in this population. So this is how much data we get out of you.
Whole bunch of data, but let's see, where is our propulsion?
The bars right there.
Can't see it. Okay. Okay, so interesting here that you actually have a certain amount of active propulsion, which Ryan didn't have yesterday. So that's one thing that's interesting, is that I think every FSHD patient has a different characteristic for their gait mechanics.
Sure.
So we'll need to normalize some of the variables and figure out how to do exactly that. But again, you're having a reduction here. This is much lower than what you would see someone of your age, essentially, who did not have a disorder. And so they should have more active propulsion while you're going through that actual gait cycle.
Right. This is something I'd like to see, because I'm like what you were saying about studies over time. I'm
And Ryan
trying to
is
throw
also
in
there if you want.
active exercising in some fashion, and even supplementation, which we can maybe talk about. To see, I wanted to see if I could, and this is, I think, could be a perfect way to measure if it actually is changing, you're getting stronger or weaker in the actual mechanics of what you do, as opposed to just a static grip or do that. I think it's.
Yeah, much more functional. And so here's an example of a healthy individual here.
where I just wanted to show you your propulsion time in a percentage based.
Right.
So you've got active, but they spend about 55% in active propulsion and about 78% in passive. So if we were to go back to yours, okay. Here's the active and passive, and here's your
Quite a
normal
bit lower,
trials.
right? Wow.
Yes, and it's funny though because a couple of these are higher than a normal person, which is interesting to me because that means that this first one that you did may not be, like we said, we take that first trial out.
Mm-hmm.
These other two indicate that you are having, in order to actually complete the task, you are pushing considerable amount. So which is different than Ryan, he had nothing. No active propulsion, but you have actually double the amount of active propulsion that you would see, like for my PhD student. Now, different age,
Sure.
different classification. He's in his 20s, and so you're going to have a little difference in variables there. But that shows that you're working twice as hard to do the same task, which is not efficient. Your gait mechanics should be as efficient and easy as possible because
Right.
essentially our bodies are lazy. We want to be in that homeostasis status. So yeah, that's something interesting. My hypothesis was that there wouldn't be any propulsion, and you actually have double the amount of propulsion, which is counterintuitive to what I actually thought.
Well, I do
Yes.
like speed.
Yes.
Well, that's where
I got the tickets to prove it on the way.
cameras because
Yes.
just the mechanics of how you walk are quite a bit different than how I walk. And actually, I think once we get the full system set up and we have the cameras actually evaluating how you move your arms, your legs, how everything is coordinated, I think some interesting stuff.
Yeah, I think the ACE 83 trial had, where I had these little markers on, and then there was something else where they had like a stick figure
Yes.
that did that whole thing, so.
Where
You were gonna do that.
We're actually starting construction next week on that. So
Fabulous.
we'll be opening up our floor and installing stuff in this thing, but we'll have a full motion capture system.
Yeah, so it certainly goes to the variability of the presentations of this disease,
Yeah.
clearly.
Yeah.
There's going to be a wide variety of how patients actually present.
So it's just more data, more sample study size, it gives you a better, clearer picture, clearly.
Absolutely.
Right.
Need that baseline for it, exactly, especially if we go to trials.
Yeah.
Brilliant.
Yeah, yeah.
And
Okay.
Hopefully to track those trials, right, we're trying to look at to see maybe progression and digression.
Oh, I think that's fabulous. I'd love to see that with the ACE 83 trial. Do you get usable muscle or a larger unusable muscle?
Yeah.
Right, and I don't know if that's really been determined quite yet, frankly.
Yeah, either. Yeah.
So, okay, I'm gonna stop this then, thanks.